Hello and welcome to lesson 5M. I can compare and contrast different properties of quadrilaterals. So we're basically just going to take all the information we've learned in the last mini lessons and summarize them in one chart so that you guys have a nice quick thing to reference. So let's just start with a parallelogram. In a parallelogram, sides, the important thing about the sides is that my opposite sides are congruent and parallel. Okay. Angle-wise, the important thing about parallelograms is that my opposite angles are congruent and my consecutive angles are supplementary. And my diagonals bisect each other. Now, what's kind of cool about parallelograms is that these same these same properties will carry down for the rhombus and the rectangle and the square, because all of these are subdivisions of this particular shape. Now let's take a look at the rhombus. My rhombus has some differences from the parallelogram. In that all of my sides are congruent, okay? And that my diagonals go a little bit further and they bisect opposite angles, and the diagonals are also perpendicular. And the cool thing about rhombus, a square is a subset of rhombi. So if we can say something for a rhombus, we can also say it for a square, just like so. And then we have our rectangles. Well, rectangles are really the equiangular version of our parallelogram. And so when we look at the sides, we can say that our sides are perpendicular, and we know from our angles that all angles are congruent, and when they're congruent they happen to be 90 degrees, and we know that our diagonals are also congruent. Okay? So those are my cool things about, or special things about, rectangles. And furthermore, we know that anything that is true for a rectangle is also true for a square, because a square is in fact a type of rectangle. So when we're looking at these, we can say that the rhombus is an equiangular, or the equiangular. Oh my gosh, not equiangular, equilateral, friends. Let me get my head screwed on straight. Equilateral parallelogram, and again, it's a type of parallelogram. That my rectangle is the equiangular parallelogram, so it's also a type of parallelogram. And my square is the regular parallelogram, because it not only is a parallelogram, it's also a rectangle and a rhombus. It's all three. So it's both equiangular, equilateral, which makes it regular. Now let's look at kind of the next branch on our quadrilateral tree. We're going to look at trapezoids now. Well, trapezoids are defined as having one pair of parallel sides, and these sides are the bases. And when we have one pair of parallel sides, that makes two pair of consecutive supplementary angles. And there's nothing special happening in their diagonals here. Now, what is true for a trapezoid is also true of its subcategory, the isosceles trapezoid. So the isosceles trapezoids also have one pair of parallel sides, which are my bases, and two pairs of consecutive supplementary angles, but it has some more cool stuff going on. Let's pick a new color, friends, shall we? What about lime green? Let's see what happens here. So my isosceles trapezoid also has legs that are congruent. Let's put an E in there, shall we? And my base, the pairs of base angles are also congruent, and my diagonals are congruent. So my isosceles trapezoid is a subcategory of my regular old trapezoid. Now let's take a look at trapeziums. Well, trapeziums are a little funky because there's always something weird going on with trapeziums, but they're basically defined as having no parallel sides. They are weird looking, generally speaking. We can't say anything else about their sides or their angles or their diagonals. They're just kind of doing their own thing. The kites, on the other hand, have some pretty cool stuff going on. They are a kind of trapezium, so they also have no parallel sides. Remember, they are a subcategory. So kites are a kind of trapezium, but they have more going on than just that. They also have two pair of consecutive congruent sides. Okay, that's consecutive, not opposite. That makes it a little bit different. They have one pair of congruent opposite angles. And lots of cool things happen with the diagonals. The diagonals are perpendicular. One diagonal bisects an opposite angles, and it also will bisect the other diagonal. One diagonal, I'm gonna call it is the perpendicular bisector of the other diagonal. Please do. Of the other diagonal. So kites actually have lots of cool properties. But anyway, all right, guys, I hope that helps you mentally organize what's going on. I've tried to kind of make a tree here for you so you can see how different things are related, and it's all color-coded. So if you have any questions, come in to see me. In fact, I'm gonna make that red to make that better. Anyway, see y'all in class. Thank you very much.